site specific, means it can be done anywhere in the state at any location. And second is that it is, or will eventually, enable collaboration between schools, thus becoming a learning multiplier. So with that as a black backdrop, we're going to go to the next slide, and it went to the wrong slide. Okay, let's see here. All right. So this one. All right, so agenda. Jason and I will first talk about how we were paired up in our initial planning. Then we're going to talk about the website we developed and how that became the keystone of our project. We will focus on the student and teacher sections with added emphasis on the collaboration. So I'm going to spin it over to Jason now. He's going to discuss our original proposal and how they merged to form this project. So Jason, you go ahead and talk, and I'll find the slide for you.
Hello. Hi. Hello, everyone. Okay, so obviously water is important, especially now we're hearing about lead and we're hearing about all these issues about pollution, you know, historically Love Canal and upstate New York. And if we don't care for these things, then we're going to have major problems down the road. I mean, we're already having, I mean, you know, you think of Newark, New Jersey, they're drinking lead in their water. New York has lead in the water. So we need to care about things and we need to understand them, and we need to know where's the lead coming from, how did it get there? Also, that's why waterways are so important. And, you know, New York, I have a friend who works for the New York Water Department, and we spend, you know, think of the EPA, how much effort we put into protecting our waterways. And, you know, even now, I mean, think about the Industrial Revolution and how much, you know, they were saying back in the 1800s, they were dumping 6 barrels of crude oil in New York City into the water every day. We used to think we jumped it in there and no big deal. Nothing happened. It just, the earth just sucked up all this stuff, but it doesn't. It ends up somewhere. And by studying these regions, we know how. And then, so Nick centralized the concept about the girl in upstate New York and her dad's using pesticides to ensure proper, you know, crop growth, because, I mean, if they don't have crops, they're not going to be able to eat that winter. So anyway, but then the residue from those pesticides goes in water and it travels down, and all the water from the continent is eventually going to end up in the oceans at some point. And so there's connections, and it's relative to everybody. And so that's why Nick's project in upstate New York and my project in Sheldrake Lake, which was a reservoir, I guess that was a cube. Okay, were so important. So I'll pass it over to Nick.
Great. Thanks, Jason. As Jason just discussed, the common thread for both of us was water systems. Water systems are great because for ages they've attracted humans, right? Everybody loves to go to water and hang out there. They're magnets. So this is also great because local, state, and federal agencies usually provide easy access to an array of water features. This project let us examine questions like, why is water flowing here? What's happening geologically that determined this river, reservoir, or stream, or waterfall? Why did it develop right here? Along with the unique geology of these areas, we can discuss map reading, terrain analysis, hydrology, sedimentology, erosion, deposition, major, minor geological systems. And key to this is letting, of course, the students discover the interconnectedness of these systems. So Jason, you go ahead now, and Jason's going to discuss how we developed the website. He had a really awesome website that we kind of spun and turned into a Google site. So he's going to talk to you about that, and I'm going to find the slide for him. There it is. Bam.
Thank you, Nick. Well done. Okay, so I got this website, and you know, like many times students, we head down the wrong path. We have good intentions, but we end up doing things that are just not what our educators or our teachers are looking for. So I started this website, and it was something I had, and I started building on it, and it was great to learn how to use it. And so basically I had this massive amount of data, and but it just wasn't what the professor was looking for, and there were better ways of distributing the information. And that's basically what the website is supposed to be doing. You know, what does the teacher do when they get to the park? How do they organize themselves? What type of specimens are they looking for? So I want to provide them with this information and give them the guidelines and the references. And also, I mean, there are sensors in the theoretical paper. We monitor ocean currents, we monitor CO2 concentrations in the atmosphere, and we monitor CO2 concentrations in the ocean. We look at lava flows, we look at pollution levels, we look at all these things. So all this information is available, and then the question is, how do we get it? How do we organize it? How do we use it? And then how do we keep ourselves sane while we manage it? So that's what the site was about. And then Nick was the webmaster in that area. Go ahead, Nick.
All right. Thanks, Jason. So Jason's being humble there. If you go to earthscienceclass.info, that's his original one. And actually, it's got a lot of resources there for everybody. The link is in this. I think you saw on the last slide. The link's in the brief. Tons of great resources there. Jason spent a lot of time and effort on it. He's kind of being humble about how awesome it is, but it is great. He did a lot of good work there. And we just spun a lot of that and funneled it down just specifically for this Outward Bound type project. So of it, you'll see this is kind of the tabs all in that project, and then it goes into the heavy section with the student section and the teacher section. So the student section has a start here area, so the students don't have to worry about where to go or what they'll be learning. All the learning objectives are right there. Next to that is a section for them to report their data. For this, we have constructed a series of exercises that enable their learning. For example, they will be required to photograph, or as a backup, find a picture online of the falls or water or rock formation or wherever they visited. They will then be asked to manipulate that photo to show the stratification, which you can kind of see in the slide that I've done here. This is for seeing the layers of rock firsthand and working with the photograph as well. So they'll see it firsthand, they'll be able to touch it and actually put their hands on those gaps and then use the photograph. The students will be able to see the rock formation as a book or a catalog of events rather than just this big monolithic mass. So now Jason's going to talk more about some of the student stuff that he provided and then the teacher stuff that he did as well. Go ahead, Jason.
Okay, thank you, Nick. So, geologists, we want to see things, we want to touch things, we want to smell things, and we want to understand them, and that's how we do it. And then that's also, the science, education, my interviews are like, they want hands-on activities. So the idea is that we go there and, if you go to a reservoir, you have the standing water, you have a dam holding that water, you have a stream, and then you have different areas of the stream. So there are many places to gather water samples, at least 3, and also rock samples. So the idea was that you get your 3 water samples, you get some soil samples from different areas, depending upon what you're looking for or where you are, and then you get your rock samples, your igneous, your metamorphic, your sedimentary, and those tell you about the geology. And if you're looking, we could try to guess where are fault lines, and then through deformation of foliation and strata, deformation, we could see historical evidence of earthquakes, so we could see compression. So there are so many things that we can learn. And then also, Sheldrake Lake is beautiful. You can walk around. There's ancient features. There's a hunting shack. Originally it was used as fishery, and then they were selling ice to New York City out of it, and then it evolved into a reservoir, and now they use it for flood control. So, and they're talking about how the Army Corps of Engineers is going to run a pipe over under Mamaroneck to handle all the excess water, and then we all know that we're going to have a lot more water. I mean, we already saw, look this year, how much water we've had. There's going to be a lot more water to come. Even in areas they're building they're lifting homes up and building sub-basements, so these are some serious issues. So these kids, they need to understand this, and they get their samples, and then these samples can be brought back to the laboratory. We could do, we could evaporate the water, and we could study the residue. We could send it out for testing. We could look at the rocks. We could do rock identification. We could, we could see, there's many things we could do with the samples. So, but what's wonderful is that all of these samples focus on a specific region that our students have probably grown up around. So it's very close to them, and then that's the focus. That's the concept. I guess I'll hand it over.
Okay. Okay, good. I'm back up. All right, so I also built a lesson plan. There are lesson plans posted to the site the teacher could use as is or manipulate for their own unique application. My lesson plan is a 2-day lesson plan that's on the website. Day 1 is in the field. It's working with a moving body of water. On the slide, you will see a young lady using a high-speed piece of technology that's a stream velocity gauge by Vernier. But with some string, a tape measure, orange, and a stopwatch, you can gather the same data. On day 2, the students then take that data, they collect it in the field into the lab. The Excel spreadsheet you'll see there on the slide can be downloaded from our site and then uploaded back to the site to share with other classes. There's also a room in the lesson plan for a conversation starter for field science versus lab science debate, and it encouraged students not to shy away from science because they hate the lab but love the field or vice versa. And I'm going to skip that last little bit we're going to talk about because I really want to talk about collaboration, which is the big part. At the beginning of this brief, I mentioned the importance of this project not being specific to any one location and that this project is collaborative. We feel that this aspect of the project sets it apart, moves this project out of just a normal field trip model. There's a connect page on the website that you go to. It has an interactive personalized Google map. Some refer to it as a wiki map. We're running short on time, and we're right 12 minutes, I think, right about now, so I'll skip the details there. But those different pins have all the information that students can share and upload, and at some point that could be full of pins. So last page here, just to wrap it all up. We developed a project that's scalable and terrible for a school to implement as an hour-long lesson or a multi-day trip. It gets the students wet and dirty if it's done right and has them hands-on with the systems they discussed in class. The project provides multimodal assessment from the artistic to the mathematic that lets students demonstrate learning through a number of avenues they enjoyed most. It allows for exponential expansion, and while it can be tech-heavy, it was built so that it is not tech-reliant. So it doesn't disqualify any school who's looking for a science field trip model to follow but doesn't have the resources. So that's going to wrap up our briefing, and I think we still have time for maybe a few questions.
Wow, and I noticed, yeah, we have Brian in the audience who lives right nearby. So I'm going to turn my mic off, but.
Hey guys, you guys did a great job. I'm also a nurse science teacher by trade, and back about 5 years ago, our school stopped doing field trips. So I love Watkins Glen. I actually went and videotaped me and my wife. I made my wife videotape me going through the falls, and there's so much stuff that you can show the kids there. And I used that video for about 5-6 days in a lesson. Good job.
Thanks, Brian. Was that Chittenango Falls or Buttermilk Falls?
I live right in the village of Chenango.
Yeah, cool. That's a super cool place that actually, if you are interested, attached to the link on the Moodle site is my original report, which is all focused specifically on the unique geology of Chittenango Falls, and it was really what got me jazzed up about this. So I have a lot of resources basically that I found about Chittenango Falls and the unique geology there. So if you want to find it, it's on the Moodle site. Thanks.
I wanted to say something. I had an interview today, and the principal asked me, what grade is this focused on? And I thought about it, and if you think about earth science and introductions, I mean, of course, I guess the district is going to decide what grade, but you could take kindergartners to the local park and just introduce the concept of water and rocks. And so, I mean, we could start earth science education pretty early if we're just thinking about introducing the concepts, broad concepts.
Well, thank you very much. We have some guests here too, and I'm going to be sharing your website links because not everybody will have the course information, but I want to be sure they have this. Jonathan just stopped in. He's doing some work on a project looking at local habitats where he is. So I think among you, there's quite a bit in common. And I guess, well, Michelle and Edwin, if you could be moving to the front, and Michelle and Edwin, it seems Edwin can talk, but he can't hear. So Michelle's going to text him in, and I will just try to, I'm going to turn something off and turn it back on shortly. But while you two get set up, and I want to thank you both, Jason and Nick, for your work. And also, I hope I remember to thank Danielle and Ashley too.